So in this third and final part of Crash Course in Software Engineering, we're going to talk a little bit about project management. So this sounds really dull. You know, you signed up to do computer science, not a management course. Except, of course, if you signed up to do the computer science and management course, in which case you should know this already. But management's a very important part of producing good software. Usually, when you're sort of working on a project, there's somebody who is responsible for the project. This is the project manager. And basically the responsibility to deliver is usually on their shoulders. So if their developers mess up, well, they didn't manage the developers properly. So there are many different attributes which make a good project manager, and there are many different flaws in people which often mean that project managers aren't very good. To me, the best project manager and the person who can produce the best teamwork to produce a particular product is someone who has really good leadership qualities. And a good leader can be defined as someone who leads. So that's someone who really wants to do things first. So someone who really knows what they're talking about, someone who really understands the process, and someone who people look up to. Leaders have followers. So you need to gain the respect of your team, and you gain the respect of your team by understanding what their needs are. And I did a separate lecture, lecture 17, on geek management, which might be worth a read. Also, we talked about something called the 7 sins of project management, highlights from which include: don't be overzealous in trying to add too many features to a product, don't expect people to work too much overtime, etc., etc. Again, it's probably worth having a look at the 7 deadly sins and trying to understand what these mean. So there are loads of books written on management of people. If you get the management of the people right, you'll often get the management of the project right and deliver a higher quality product. And this comes by trying to understand not just the requirements of the product, but the requirements and desires of the people who you're working with. For example, if you're leading a team of developers, you need to make sure that they've got the right tools, the right equipment, the right debugging software. And knowledge of what these things are actually means that you're a better manager. So even if you're not planning on being a developer, even if you're planning on being a consultant, it's worth understanding what tools developers need and how they go through their process in order to be a better manager. One of the most easily accessible aspects of project management from our perspective is the ability to chart your progress. These things we're going to come up time and again, is being able to display progress in terms of a visual chart. The most common form is called a Gantt chart, which simply shows time along an x-axis, tasks along a y-axis, and how long each task is going to take. So as each task gets completed, you can see how far along the timeline you've actually progressed. And this is actually a really standard way of charting a particular project or charting the development of a particular product. And these have been used for many, many years in many contexts, and most people in business or in industry know what a Gantt chart is and know what it looks like. And you can also plot dependencies between tasks on this. Plotting the dependencies is important because it allows you to see the critical path through a particular project. The critical path is a series of tasks which must be performed before a project can progress. So for example, you can't build a house until the foundations have been laid, or you can't develop a piece of software until the framework is put in place to allow the developers, or more fundamentally, you can't develop a piece of software if the order for computers for your developers hasn't come in on time. These critical tasks form a critical path through a project. And if you were to extend the duration of any task on the critical path, you are extending the overall project time. You want to avoid doing this because this introduces a delay into a project, of which, depending on the project you're working in, can ultimately incur a penalty. And looking at a Gantt chart and using other tools such as critical path analysis or PERT charts, which of course we touched on as well, Combination of these methods can allow you to see where the bottlenecks are in your project. So where you need to add more resources in terms of manpower or in terms of time. We also looked at an alternative method of charting progress called Milestones. So you measure deliverables not in terms of these individual tasks, but in terms of having reached specific stages of functionality. This is what they teach at the London School of Economics on their MBA course, because it's seen as a much more flexible yet understandable way of charting progress. We also looked a little bit at the management of geeks. And when it comes to the management of geeks, you've got to think, well, what would my geek want? You've got to take care of them. But I'm not going to go into that today in too much detail. I feel like I've told you pretty much everything that there is that I can do, say, within an hour on software engineering. So to finish, I'd just like to summarise with drawing reference to what we've had in the lecture content, in the course content and in the coursework, and how this relates to the teaching objectives which we laid out at the beginning. So the idea of this module and the idea of this course was to introduce the software product lifecycle and the development cycle placed within the context of software engineering and put this into the framework of a computer science degree. Some of these principles and some of these tools should hopefully be applicable to a number of modules that you complete and a number of tasks that you'll be expected to do in the workplace once you leave us. We've aimed to give you a taster of the various different methodologies, not just so that you understand the words, but when you're working on various different projects, so you'll be able to select and use the most appropriate one. Or you'll be able to take elements from the different methodologies and combine them to make the most effective methodology for what it is you're trying to do. This relies on you understanding the advantages and the disadvantages of the different components of each methodology. We wanted to give you some experience with the practicalities of software engineering. This formed part of your coursework. As part of that, you worked in pairs, you developed a game, which was language independent, you produced a report, which is your documentation, and you had to pick a methodology to work with. So there we were reinforcing the concepts that we taught. And we also wanted to introduce you to the various different tools that a software engineer might use in order to develop good products. This includes version control systems, debugging, and testing frameworks. So that's pretty much all I have to say on the matter today. Good luck for the exam tomorrow, and see you all next year.